My name is Joshua Blackman. I had done research since I was 15. Okay? Actually 12, but I don't count that. So, I have 3 hypotheses and 2 theories. I'm calling them theories not because they went through scientific consensus, but because there's evidence that backs them up. I am willing for them to be scrutinized and go through scientific consensus. I'm willing to hear counter facts. I'm willing to hear counter arguments. So far, every argument I have gotten has been not an argument that resolves my theory or pushes my theory away, more so as, well, you're making a premise that, or you're saying that, or this is a fallacy, or that's a fallacy, and not explaining why one thing is a fallacy and another. That's called the fallacy. If you claim that an argument is invalid because you see a fallacy, but you don't explain why it's a fallacy, that is the fallacy. And there are several fallacies, and I'm not going to bore people explaining them all. It's also dismissive in the philosophical community, where in the philosophical community they say, well, you can't come up with an argument for God, even if you had evidence, because you're saying that some incomprehensible being. Well, first of all, my argument can lead to God. My argument is not necessarily in accordance or about God. In fact, there are properties of it that aren't about God. Second of all, we talk about incomprehensible things all the time. We put them in a comprehensible frame of thought. We put the universe in a box. Okay? We put the atoms of a universe in the box. We put the material of the universe in the box. We put all the quantum formulas that make up to the atomic level, and then we put all the forces on the atomic level in a box to the mass level where there's gravity, and then we put, and yes, there's gravity below the atomic level, but we don't detect it, and we put all of that on the level of the universe, which is 13.8 billion light years in radius, and that's been calculated to be 10 to the 81th power. Now, not only is that fact alone incomprehensible, but that the whole system built up is incomprehensible. The whole timeline to that predicament, this is cosmology, is incomprehensible. It's not that it's not objective. It is certainly objective. So calling something incomprehensible, like people always do, is calling something incoherent, is not a counter argument. Willing to talk about the facts, willing to scrutinize where I went wrong, maybe, that would be an argument. So forget about the fact that, well, if you say some incomprehensible being created the incomprehensible beginning, that is not a fucking argument. This is where I know that Stefan Molyneux has been debating for 30-something years. I know I'm only 25, etc. But I've been researching since I was 15. Physics and all that other stuff, and he doesn't want to debate physics, but I'm putting it into a philosophical realm. I'm putting it into a sensical realm. I'm putting it into a classical sensical realm. Okay? When you put something into a classical sensical realm, like for instance, this is my problem. If somebody says that, well, I'm sorry, I don't know what you want to argue about because you're all over the place. You're in like 4 or 5 different sciences, and I just want to get it onto one topic. What if all 4 of those sciences actually lead to the fucking debate topic? You completely crippled the person who had a valid debate topic. Just to benefit you. So let me get into my theory. I'm willing to debate it with anybody, philosophical or scientific. So I actually want to start it from the philosophical point because it's a lot easier to talk about it. It's more comprehensible. It's not incomprehensible at all, almost, in the philosophical argument. So the philosophical argument is this. It is a naturalistic argument. If the laws of nature created the mind, the human mind, naturally over millions of years of evolution, causality, millions of years of causality for the solar system to get a certain way, for the Earth to get a certain way, and for the galaxy eventually to get a certain way, billions of years ago. If the laws of nature set that in motion, eventually we get to where we are now with a biological mind. Natural laws created a biological mind. What is stopping those natural laws from creating a non-biological mind? In other words, the mind, this is the second argument, the mind is built up of tons of complexity, time complexity from the past, biological complexity of information all the way up to the reptilian, subconscious, and frontal lobe. That's the brain. And that complexity of the brain with 100 billion neurons, basically a galaxy's worth of stars, if neurons were stars, in the mind, in the brain, I mean, allows the emergent property of a mind. What is stopping the complexity of the universe if a mind is built up of complexity to have an emergent property we call mind? That is my philosophical argument. This isn't a teleological argument. This isn't a God is in the gaps, therefore it must be God argument. This is a theory of what's stopping the universe from being a mind. And I'm going to get into the scientific argument. Evidence for clarification. If, not even if, let me get to, I already talked about the complexity of the body. There's cellular complexity, DNA complexity, time complexity. So we evolved so long ago. Time is a factor in that, time complexity. And, you know, the photons hitting our body over that period of time, and any one factor could set that off. That is the complexity you get to when you get to the human body, the human mind, with 100 billion neurons. Now, it's just a matter of fact that a theoretical physicist made a claim and a statement, not a theory, but a statement, that it is evidentiary with his colleague who's a neuroscientist that the human brain is a biological quantum computer. And, well, here's a hypothetical but I don't need a hypothetical because there's also a fact that I can mention as well. So I'll mention the hypothetical first, and I'll mention the fact later. So hypothetically, if we had a powerful enough computer, we can emulate the brain and therefore emulate the mind. Second part, even if the human brain is not a computer, we've taken 90,000. One sec, I'm going to wait for this. We've taken 90,000 computers. This was like in 2008, 2010. This is a matter of fact, and built a simulation of a neuron system of a brain with computers. We've already done it with computers. Not the complete brain, but a part of the brain. If we can use a complete brain with 90,000 computers, then it's just a matter of how many computers does it take to build a mind. Not whether it is if I say this is just a matter of fact in computer science. If I say that there's no way that I'm going to get to 16,000 gigabytes or RAM, 16,000 gigs of RAM. Sorry. There's no way I'm going to get to 16,000 gigs of RAM. And computer science did look at me stupid, even though it might not have ever happened. They'd look at me like I was stupid because it's just a math problem. It's an empirical math problem that if I added, even if I couldn't shrink something to fit 16 gigs of RAM in one object, I could just add RAM until I eventually get to 16,000 gigs of RAM. That's a matter of fact. So, and then it becomes a matter of materials and all that other stuff, but generally there is enough materials to get there. Now, I'm not saying that the mind isn't powerful. Of course, the mind is completely powerful. I'm just saying that the mind can be placed onto a material object, like a computer, and that material object, although it's certainly not made of the exact same complexity, but its own complexity can emulate a mind. That is a fact. So if I go into this is what I'm talking about: three pillars of science: neuroscience, physics, and cosmology. So I'm going to talk about cosmology now. I talked about neuroscience and physics. And cosmology, they have something called networking cosmology. In networking cosmology, there is a thing, and I'm not using this as an argument, I'm not, but there's a thing called the Boltzmann brain problem. The Boltzmann brain problem doesn't say that universes make minds. The Boltzmann brain problem says that if you have enough complexity in your model prior to the Big Bang, then you could make a mind. Your model might be flawed. So, and it goes even further. So, in networking cosmology, natural laws of physics, in and of itself, can have enough complexity to have an emergent property of a mind and therefore an observer. In networking cosmology, if we go after the fact of the Big Bang, because I want to keep things simplistic, there are networks of atoms, planets, solar systems, galaxies, gravitational pull between galaxies, and then there's dark energy in between it all, and they all affect each other in some form or fashion, or have affected each other in time. So, and I'm saying this is falsifiable. Therefore, it can be argued. It's falsifiable for a couple of reasons, but I'm going to argue why I don't think that it is false. So, but in networking cosmology, there can be networks held by the forces at all. And the thing about that, held by the forces, I'm not trying to make it vague, but because they're held by the forces, there are causals and effects that keep and retain information. Just like if you were to put electricity and certain bits into a computer, those bits are retained in memory. So there are things that retain information. That doesn't mean that it's a mind. But on top of that, there's energetic frequencies throughout the universe, and information is objectively, this is where I go back to physics real quick, it's objectively faster than the speed of light. Information is. Because, well, when you have two entangled particles, one flips, the other flips, that's saying that information is faster than the speed of light. I do not believe in making up quantum woo arguments. I'm just saying that information in general is objectively faster than the speed of light. But even without that fact, because information can be retained in objects and throughout time, here's the argument. If I took the universal timeline of 13.8 billion years and I shortened it to an hour, or I shortened it to a day, or I shortened it to 1,000 days, the issue isn't my idea. If I did that, it could be evidentiary that while things retain information, they have the same flow as you would expect a brain to have. And therefore, it could theoretically produce a thought, or several thoughts, or thousands of thoughts, or millions of thoughts, or billions of thoughts, based on the causality of the universe from the beginning, because it's so complex, to the end. That thought could have been developing for, like, think about it this way. Your subconscious is 600 times faster than your conscious brain. Your subconscious produces thoughts for your brain, filters thoughts for your brain. If you slowed the subconscious down to the speed at which the universe gets from 13 billion years ago to now, it would appear that it wasn't doing anything. But it is. It is calculating a thought, even if that thought takes millions of years to be processed. And by the way, it wouldn't be much of a problem for the subconscious brain, because the subconscious brain can calculate 1,000,000 thoughts in roughly like 5 minutes, or at least in a day. So you would get millions of thoughts in the time span of the universe. And it's not consistently all in the same place. So my argument is that the universe could be an emergent property of a mind. What is falsifiable about this argument? And here's what is falsifiable about this argument, is how can I test it? Because I believe it can be tested. Is if the universal frequencies, if the universe has frequencies, which it does, and they correlate to holding information filtering information and pushing out what could be fundamentally a thought. Basically, the same frequencies in a brain which can be calculated to push out a thought. If the universe mimics that, or parts of the universe mimics that, then it is, by all definition of what a mind is, the universe has it's not a brain, but it has more complexity than a brain, and thus it could have the emergent property of a mind. Just as a computer, it is not a brain, and a brain is not a transit. It doesn't have trains of transistors. It has neurons instead, but they all push information. Doesn't mean it can't have the emergent property of a brain, which is a mind. It is falsifiable. I gave ways in which it can be falsifiable. They've already have experiments, not experiments, but data. Data, it can be used to falsify something as well. Observation is a part of science just as much as experimentation. And they have received frequencies from the universe, which I imagine from the end of the universe as light's traveling to now, which would have been like millions of years. It had to go through gravity, it had to go through all kinds of other stuff to be received in a frequency of a thought. And that is what, there was another paper written, I forgot where, but I'm going to put all the references in the bottom of the video of how the frequencies were almost identical to that of a brain. I don't have any particular feelings about this. Initially, yeah, I do, because that's a scary thing to think about. It's like, well, or it's an odd or weird thing to think about that the universe could have the emergent property of a brain, but weird things are apparent in nature. When you're talking about stuff outside your environment, you're going to find weird things. Black holes were weird for the longest time. Weird things are apparent in nature. Just because this theory is weird does not mean it is wrong. There's a difference. So, I don't have a counter argument. I tried to produce a counter argument, and that's unfair because others haven't produced a counter argument to the three pillars. Because you got to understand that science, biology, physics, and all that other stuff all play together. They don't, just because they have different sections doesn't mean they don't play together. Like, physics plays into biology at some fucking level. Quantum mechanics plays into physics. It is a form of physics on the smallest level, and you can use quantum mechanics in some of the larger levels. And cosmology obviously plays on almost all those levels, because I think it goes into evolution as well, but I'm not 100% sure, and I don't want to say that it does for most assuredly, because, well, I don't want to be wrong on that. I just know about the fact that it studies the stars in the universe, and the before the Big Bang and after the Big Bang. There's people who get really specific and really precise and correct me. It's like, well, the Big Bang wasn't an explosion, and that's what I'm talking about, is that it could have just been super complex and got more complex and more expansive. Ancient theory, stuff like that. I don't go into the idea that there are multiple universes. I understand that there is in theory, but I don't say that, well, there may not be a mind in our universe, but there could be a mind in another universe, because that is unfalsifiable. And two, I mean, that's fun to think about, but it doesn't do anything for me. Just because other Boltzmann brains can exist in the multiverse doesn't do anything for me. That's why I talked about the after effects, the after complexity, because complexity grows. And that's it. If you have any questions at all, because I could virtually answer a lot of questions on the topic, I'm willing to accept comments. If you're going to insult me, it's not going to change my mind on the topic, and I don't think it's going to change people's minds who accept the theory on the topic.